Hello, my name is Diogo Carvalho, and I'm a Master in Sports Training. I am a collaborator of Faculty of Sports of University of Porto, and I'm also a swimming coach. In the current presentation, I will talk about the sprint testing and training. The capability to produce mechanical work in human locomotion is ultimately determined by the ability of the muscle cells to provide energy by means of two distinct but integrated metabolic processes, the anaerobic and aerobic pathways. That is, the degradation of macronutrients in the absence and presence of oxygen, respectively. However, it can be referred as a three-system dichotomy where the anaerobic system is further divided into a lactic, the phosphogen splitting, and lactic, the non-anaerobic glycolysis that promotes the breakdown of carbohydrates to lactic acid. Sprint, as a capacity, consists of the speed of execution of a given motor behavior, to swim, to run as fast as you can over a short distance. From a physiological point of view, sprinting seems to be integrated in the lactic anaerobic system, which involves the separation of high-energy phosphogens, which together with ATP stored in the cell provide the immediate energy needed in the initial phases of intense or explosive exercise. However, the duration of this, also is usually called ATP-CP system, is not the subject of consensus in the literature, and it is reported only a few seconds or up to 30 seconds. We believe in a conservative way that this system can be explored somewhere between 5 and 10 seconds based on maximal velocity exertion graphical analysis. Newer investigations showed controversial results regarding expression of sprinting efforts. In swimming, after 5 to 7 seconds of all-out swim in 3 of the 4 conventional swimming techniques, high increments of lactate concentrations were observed, evidencing very high rates of anaerobic power in efforts less than 10 seconds. However, it is important to refer that the lactate concentrations increments observed in the current study for such short and explosive swims might only be possible for subjects with very high levels of muscular strength and power that can make an effective activation of the fastest muscle type 2B fibers in response to a very demanding external load. In fact, in another even more recent study, top-level runners showed greater lactate concentration increments when compared to their sub-elite counterparts after very short maximal efforts of less than 3 seconds. This suggests a great glycolytic contribution than previously reported in this type of efforts. However, ATP-CP, instead of being an energy system, can be considered as a temporal energy buffer that operates at sites of high energy translocation and that anaerobic glycolysis is recruited at onset of exercise with the glycolytic pathway increasing almost instantaneously. In fact, after only 6 seconds, energy derived from this pathway can account up to 50% of the total energy demand, and we believe that in elite athletes that the percentage might be even higher. Competitive swimming goes from distance of 50 to 1500 meters, meaning that the swimming can go from 20 seconds to more than 50 minutes. Depending on the distance swum, different tactics are implemented by the swimmers, from all-out efforts in short bouts and pacing control efforts in longer bouts. However, even in long distance, swimmers have moments where they swim as fast as they can, in starts, some turns, and in the last swimming lengths. It is possible to understand that depending on the distance, it will impose different intensities and specific energy demands on metabolic system. In the events, some tactics procedures can be adopted depending on the competitive distance, opponents, and level of the swimmer. Independently of the events, the overall swimming performance is a result of starting, swimming, and finishing and turning times. Therefore, the sprinting can be decomposed in 3 main components: the reaction speed of the great applications in the starts, the cyclic speed observed during the different swimming courses, and the cyclic speed which is visible in the starts in the turns. The latest protocol presented in the literature consists in one 10-meter clean swimming, starting from the 40 meters marks until the wall, and two 15 meters bouts, one with a block start and another with a wall push, at maximal speeds in their best swimming techniques, with 10 minutes rest intervals between each bout. Times are assessed using a digital chronometer, and blood samples are collected from the fingertip for blood lactate concentration assessment before and 30 seconds after each maximal bout using a portable lactate analyzer. Also, it can be used video recording with pool and swimmer markers for biomechanical and instantaneous velocity change analysis. There are some concerns when choosing exercise, namely jumps, turns, wall pushes, and number of repetitions. The first three increases the anaerobic lactic contribution, namely in top-level swimmers. The number of repetitions will influence the anaerobic contribution of selected sets. The evaluation of sprint can use different types of exercise with different output stimulus, auditory, visual, and tactile, trying to react quickly to the stimulus. We also suggest using starts up to 50 meters, followed by glide and performing the first actions of upper limbs at maximum intensity, repetitions of 20 meters at maximum intensity, and repetitions of 25 meters with 12.5 of swimming at maximum intensity, 12.5 meters of swimming at normal intensity. Also, we can use 50-meter repetition, which is swimmers perform 20 meters of normal swimming, 10 meters of maximum intensity, including the turning, and 20 meters of normal swimming, or also choosing some parts of the 50 meters or the technique of leaving the wall, turning or reaching the wall at maximum intensity, while the rest of the course is carried out at low intensity. For sprint training, we suggest up to 4 times 50 meters when we choose 15 meters maximal, 2 times 100 meters with 20 meters maximal starts, and also up to 4 times 50 meters maximal with jumps with starts, and 35 meters with technique. Independent of the swimming technique, the sprint training will help to optimize underwater phases, to have more powerful lower limb actions, to improve limbs action synchronization, to optimize respiratory cycles, and to improve the finishing velocities. So, even without great consensus in what type of energy source is mainly recruiting during sprinting, its training and testing is highly important for overall performance, and the criteria when choosing sprinting exercises for testing or training and its durations depends on the achievements of the peak velocities and their maintenance. Thank you all for the attention.
Yeah.